Hi, this episode we're going to learn the basics of the structure of the atom, also known as atomic structure, needed for both Key Stage 3 and Key Stage 4 GCSE sciences, including chemistry and physics. So listen carefully. You'll only need to write something down when told to do so and when to pause the video. Let's go! So I'm going to make this easy. By the end of the lesson, you should be able to describe the structure of an atom as a nucleus containing protons and neutrons surrounded by electrons in shells. You will be able to recall the relative charge and relative mass of a proton, neutron and electron. You probably don't know it yet, but you'll be able to explain why atoms contain equal numbers of protons and electrons. It looks a lot, but it's not. You'll be able to describe the nucleus of an atom as very small compared to the overall size of the atom. And last but not least, you should be able to recall that most of the mass of an atom is concentrated in the nucleus. So let's start right at the beginning and describe the structure of an atom. So this is the sort of diagram you're going to have to label in your exam. And it shows that an atom consists of a nucleus at the centre containing protons and neutrons surrounded by electrons in shells. So draw and label the diagram now and copy the description for your notes. So pause the video while you do that, it shouldn't take you very long. So that's the first bullet point done already. Let's move on to the second. You need to be able to recall, that means remember, the relative charge and relative mass of a proton, neutron and electron. And by relative here, I mean how they compare with one another. So let's start with the relative mass. So how does the mass of the subatomic particles compare with one another? Well, protons in the nucleus, we say, have a mass of 1, but electrons have 0 mass in comparison because they are so small. And neutrons have a mass of 1, just like the proton. So, in other words, the same mass. They are also found in the nucleus. But they're all different when it comes to their charges. So how do their charges compare with one another? How do you remember this? Think. P for proton is like P for positive. So protons have a +1 positive charge. So electrons have the opposite charge, -1. And neutrons have 0 charge. You can remember that as sounding a bit like neutral. So neutrons, neutral charge. But if you're asked what is the charge, you must say 0. So you need to make a really nice, neat copy of this for your notes, because a lot of the things you're going to do next all depend on you knowing what is in this table. It is so important, so keep it tidy. So pause the video and quickly draw the table. So next we're going to explain why atoms contain an equal or the same number of protons and electrons, but there's a clue in the table that you just drew. So if an atom has the same number of positive protons and negative electrons, the charges will cancel, meaning that the atom is neutral overall, it has no charge. Time to pause the video and write it down. So here's an example from the periodic table. So sodium has the symbol capital N, little a, but there's a number 11 next to it. What does that mean? Well, it means it has 11 positive protons in the nucleus. But we've said atoms are neutral overall, they have 0 overall charge. So this means they must also have 11 negative electrons going around in shells. Pause the video and write it down. Here is another example from the periodic table. This is chlorine. It has the symbol capital C, lowercase l, and it has the number 17 next to it. This means it has 17 positive protons in the nucleus, and those charges are cancelled by 17 negative electrons going around in shells, so the overall charge is 0. Time to pause the video and copy down the example, ready for you to do one next. Okay, so this is boron. So using the last two examples, think of this as an exam question. Explain why an atom of boron is neutral overall. So pause the video and then we can check your answer. So hopefully you wrote boron has 5 positive protons and 5 negative electrons. So the overall charge is 0. So now you can explain why atoms contain equal numbers of positive protons and negative electrons. It's so that the charges cancel and atoms are neutral overall. So just 2 more bullet points to go. So it's as simple as this. The nucleus of an atom is very small compared to the overall size of the atom. You need to write that down, but just think of one atom blown up to the size of a football pitch. The nucleus is the equivalent of just the ball at the centre of the pitch, with the electrons going around the edge of the pitch, and everything else in between is empty space. And that leads us on nicely to the very last bullet point. Okay, so we need to write this down. In the table earlier, you wrote that protons and neutrons have a relative mass of 1. So that means the same mass as each other. But they're found in the nucleus. So that's where most of the mass is concentrated in an atom. But the electrons in shells have almost 0 mass in comparison. But in between, in the atom, everything else is empty space. Okay, so to recap what we have done in this episode, we've described the structure of an atom as having a nucleus containing protons and neutrons surrounded by electrons in shells, and you drew a diagram to show that. You need to be able to remember now and recall the relative charge and relative mass of a proton, neutron and electron. So that's the information in the table showing how those things compare with one another. You need to be able to explain why atoms contain equal numbers of protons and electrons by referring to their charges and saying how, because the number of them is the same, the charges will cancel. You then need to be able to describe the nucleus of an atom as being very small compared to the overall size of the atom. So think of the football pitch analogy, with the nucleus being the ball at the centre of the pitch and the electrons going around the edge of the pitch like in shells. And then finally, that most of the mass of an atom is concentrated in the nucleus, because it's the protons and neutrons in the nucleus that have mass. We can ignore the mass of the electrons going around in the shells, as they have almost negligible mass in comparison. We can ignore it. Okay, so we've come to the end of this episode now, and I hope you're going away with some great notes that you can use. But in the next episode, you are going to need a periodic table just like this one from a GCSE paper. You don't want to use a periodic table that's different to this style. In other words, you just need the numbers across the top there, from 1 to 2 on the left, and then on the right hand side 3, 4, 5, 6, 7, 0. No other numbers. And also, if you look at the numbers at the top of each element there, they are whole numbers, the vast majority of them. So you don't want a periodic table where it's to 1 decimal place or more, just whole numbers. So in the next episode then, we'll learn more about what the numbers on the periodic table mean. You need to know quite a few things about that, and also about isotopes. Okay, so subscribe to the channel and then you'll be notified when new videos become available too.